So good morning, good afternoon, good evening, everybody. Thanks for joining our MPAI presentation about neural network watermarking. Of course, we have to start by precising the field, the topic of application, and that it's neural networks. It's hard to say something new and something appealing about these fields that about everybody speaks. Just maybe to draw the attention on the dynamic behavior of these fields. It's not only that neural networks are today deployed in practically all type of domains and that it's hard to imagine a field in which neural networks are not in use. It's not only about unmanned vehicles or robots, but in the very intimate decision on which life of people sometimes might be depending on, like medical decision making, we also find artificial intelligence algorithm built on top of neural networks. And this field, it's also in a continued renewing. A solution emerges each day, replace former one, and contributors are very broad from academia, from industry. And when I say industry, everybody knows that this cover from startups to the largest companies worldwide. So why watermarking? It's useful for neural networks. First of all, and although I'm a researcher myself, we are faced with reality. If you want to buy or to even to rent some AI solution built on the top of neural networks, the prices reaches very quickly 4, even 5 digits. So they are AI solution, professional AI solutions that can be bought up to 300,000 US dollars or to be rent on a leasing basis to 40,000 US dollar a year. So it's a very, very costly field. And that means that both the provider, the seller, and the buyer are interested in protecting themselves. The owner wants to protect their intellectual property rights. They want their solution not to be illicitly used. And on the other side, the buyer wants to be sure that the service it's really provided by the solution he bought. So in the usage, in the day-by-day usage of neural network, an AI solution can use multiple alternative neural networks to provide that an inference, a service built on top of it. So identifying the ones that really produce the inference, it's important for the user. Such solution can be also shared among multiple users, be them belonging to the same organization or derived one. So keeping the track of the process of who is an authorized user, it's always very important. And as everybody knows, and I already mentioned, as this solution are involved at the heart of critical decision-making algorithm, any malicious modification in their behavior should be identified. So we need to ensure traceability, we need to ensure integrity, we need to ensure authenticity for neural networks. This becomes mandatory. And if we sum up these 3 words, this brings us to the watermarking. As known, as inherited from the realm of multimedia processing and distribution, watermarking means to insert some additional data into an original content while observing to two constraints, to the imperceptibility and to the persistence of the inserted data. We can also call that imperceptibility transparency. That means that the usage of the multimedia content in all time, or the inference produced by the watermark by the watermark neural network for this specific application field, should not be depreciated by the watermarking process. By robustness or by persistence, we understand that this extra data should be there, should be inserted there, and any malicious attempt to get rid of them should be unsuccessful. So we say that even attacked or modified version of the watermark content should still allow the watermark to be detected. And the data payload, it's the size of embedded information. It can ranges for 1 bit, so just you obtain, yes, this content, this neural network was watermark, or no, it was not watermark, up to elaborated multiple bit data payload expressing user identity, owner identity, buyer identity, maybe some URL pointing to some complex data usage agreements. Again, watermarking means imperceptibility and persistently inserting some data into non-original content. While the definition is practically the same as in case of the multimedia content, watermarking neural network, it's a new challenge. First of all, it's because the content to be watermarked, the neural network itself is no longer static as it was the media, but it's dynamic. We cannot imagine now that we have some neural network already fixed and we come with data or things like this, but the two processes are sometime merged. So we can insert the watermark during the training process. And on the detection side, sometimes we do not have access really to the contents that was watermarked, to the watermark model, but we have to detect the watermark from the inference produced by that watermark content. So we see here that specifying, designing watermarking method for neural network, it's a new challenging task that is covered by research activities. In our MPAI standardization process, we are not interested to the process of designing this new method. We are at the pragmatic level of the usage of these solutions, and we want to specify and to see how we can evaluate the watermarking performances in the neural network case. So we identify a collection of use cases that can be much declined and customized according to specific needs. But for this presentation and as just launching the discussion, reflection about that, let's consider 3 of them. First of all, it's identifying a neural network. That is, the data payload brings only information about the neural network in itself. So here the detector should tell you something like this is neural network number 007. Another use case is identifying the actors of a neural networks. Other way stating it, the watermark should bring information about the owner, the proprietary of the neural network, maybe about the legal user, maybe about the user to whom the first buyer might license that model. And we identify the neural network. We know which are the parties involved in its usage. And the third use case we consider relates to the integrity. How can we check whether a neural network was not modified, maliciously modified, um, uh, uh, before its actual usage? Now, malicious word here in integrity verification may be very broad. Maybe it was modified because something like transfer learning was applied. Maybe a pruning was applied, but also here it's the idea of identifying the adversarial attacks and that it's of particular interest for various neural network use cases. So the scope of MPAI NNW standard, MPAI NNW standing for MPAI neural network watermarking, is to specify methodologies to evaluate the following aspect of a neural network watermarking technology. First of all, the impact on the performance of a watermark neural network and or on its inference. This much relates to the imperceptibility evaluation. So how much the performances of the watermark neural network differs from the original performances. Second one, how well a neural network watermarking detector or decoder can detect or decode a payload when the watermark neural network has been modified. So this is the translation of the robustness property in the framework of day-by-day usage of a neural network. And thirdly, the computational cost of injecting, detecting, or decoding a payload in the watermark neural network. Of course, we do not make a stance on what are these desired property, as there is not a unique solution fitting all needs. Sometimes there is a trade-off to be played, to be reached. Sometimes maybe we accept more sophisticated inserting technique, hoping and obtaining a significant decrease in the on the detection side. Maybe sometime we want the watermark to be robust only to a given extent, and then the detector to fail if some threshold in the modification is reached, and so on. So our standard is about evaluating these properties. It's not about judging these performances. We just evaluate it and we provide the means for evaluating it. And specifically today, we speak about reference software. Of course, the specification of the software is available both as an MPAI standard on our community webpage, but also I shall come back later as an IEEE standard. So let's have a focus now on the reference software. What do we understand by reference software in this case? The purpose of the MPAI NNW-RS is to provide an instance of the MPAI NNW for the image classification task, and in parallel, to ensure a seamless integration of the neural network watermarking in the conventional neural network workflow. So this second point, it's new, correspond to this new release of the reference software. And if you allow me to state it differently, what we target here is to provide the user with tools, with software interfaces, allowing the watermarking insertion and detection to be seamlessly added to conventional neural networks workflow. Our reference software, it's a backend. Developed in Python. It has two key components. injector and decoder. And as we target specifically image classification task, we already provide a reference implementation for several state-of-the-art watermarking algorithm. This reference Python implementation may be direct integration of the software made available by the technology, by the methodology provider, or can be re-implementation we did with the specific task for method just presented in the literature. We have two key software components, the injector and the detector, and we have some demonstration on how this can be used for evaluating the property of the algorithm. We consider here in this example, and you'll find on the MPAI community resources some video content for how to evaluate seminal method, the basis, maybe as far as we know, at least the first neural network watermarking method, the one provided by Uchida. And our software is very versatile. You just have to put the method name, to provide the training data sets and the testing data sets, and then everything goes smoothly as usual when using a neural network application. So for the robustness evaluation, we provide several type of attacks. Attacks here again understood as modification of the watermarking model, be them malicious or not. To stress this point, we put here quantizing operation, coefficient quantizing, which is not necessarily a malicious operation. So the reference software just need the modification ID, and the standard provides all possible modification and the ID for them. The parameters for that modification, for instance, we need to say that it's a quantization, and that this quantization is done by a parameter of 16 or of 8 or of 4 in this example, and the test data. Computational cost evaluation, it's understood here as evaluation of the memory footprint and of the time required for the execution of the algorithm. This example shows a little bit what I just say. It's a heavy unbalanced trade-off. The execution time, it's in the range of 27 seconds, and the detection is in the range of milliseconds. Let's see now what is new with the new version of the reference software. And what is new here is how easy it's to integrate the current version with conventional work NN workflow. So we consider here the question answering AIM. So question answering, it's a different topic of work from MPAI. And just to illustrate it, you have an artificial intelligence to which you provide that image you see on the upper right side of the screen, and you like to see what city is this picture taken in. Okay, for this particular would be easy to have the answer, but this is just for illustration purposes. So what is the example? We suppose that we have a user that acquires a question answering AIM from the MPAI store. And during the exploitation of this AIM, he will be he will need to be sure about the authenticity of the inference produced by that AIM. So this is a two-side issue. The technology provider, the AIM, the question answering AIM provider will like to preserve the MPAI rights. The user would like to be sure that there is no counterfeiting intervention, that the AIM it's really the one claimed to be, and also will be willing to know that no malicious adversarial tampering procedure have been applied on that solution. So to this end, we shall watermark the AIM prior to its distribution, to its downloading from the store. So we put here the diagram. It's the lower right representation, where this workflow, it's represented as an MPAI AF application. So you find here the names of the modules generally in use under MPAI AF. So the user agent, the control, the AIF, the question answering AIM, and here we are representing the decoding part as an NNW decoder. Of course, all these modules beneficiate from the general MPAI AIF facilities like communication, global storage access, and the storing itself. What is the main novelty? And the main novelty is that for this work, we came with a Python-based MPAI AIF implementation that can be used for these watermarking purposes, but not only. This is just a particular case. We represented AIMs as Python classes with attributes being the port and the run function. We built the controller and user agent as a client server application. And the metadata represented by AIM and AIW are JSON represented and are parsed in a fully automized manner for the standard topologies. We also provide with this implementation hooks for C code. So although the solution, the reference software, it's Python, modules, particular modules achieving NN task can be developed in C. So I think that now I shall let Carl Satrias to present directly the live demo about that. So I shall stop sharing my screen. I shall be back for conclusion and for discussion, but for time being, I stop sharing my screen and I switch off my micro.
But yeah,
What? Sorry. Okay.
you should start from the beginning again because the recording has restarted.
Okay. Okay, sorry. So hello everyone, I'm Carl de Souza Tires and I will present you the Python AF implementation using the use case I just show you. So as it was presented, we have a client and a server. So let me just start the controller side. And I will use the right window to give the input. So for example, I can ask for help, what kind of command I can send to the Python AF. But in my case, what I need is to parse the JSON. So I will use the command get parse. So here it opened me a window. In this zip folder, I have the JSON and the AEMs needed by this use case. So it will wait a bit and parse it. Just to show you, inside we have the JSON of question answering and the needed AAM, so the question answering and the NNW proof. So now I can, since it's parsed, I can run it. It will first ask me for a question. So we say, in which city this photo was taken. And then it will also ask me for the path to the image. So here it's called Merion PNG. So it's the same that Mihai just showed you before. And it's, go back. And I double click. Now it will take some time to proceed the NN. And then we will obtain the two outputs. So one, it's the answer of the model. And the other one is the proof of an authenticity. So here we see that the NN states that it's Singapore, and that it's really the AM we ask for. So the proof of authenticity remains true. But I will give you a second example when I altered the model. So I open the JSON, the files, the AM file, sorry, and I change the inferencing of AM. So this is a simple use case. It's just that I have an uppercase or not, but it's just to show here I've just altered the model. I save my changes. So I altered the question answering AM. So if I launch back my command, serialize again. So of course, since I reinitialize the controller, I need to parse it again, but this time with an altered question answering AM. So it's parsed. And then if I run again, I will ask, to be fair, I ask the same question: in which city this photo was taken? And I give the same input, so the same PNG, just goes in menu PNG. And it should also answer, but this time the proof of authenticity will be false since we have altered the question answering AM. So maybe it will be better to do it at the end, but we have a controller file that do the JSON parsing, and we have some MPAIs that are based on the AF standard, but I will let Mihai do the conclusion part. So let me stop sharing.
I'm coming back and I share again my screen and yeah. Okay, so here here is the slide where I stop speaking. So these are merely the demo and for the records, and to find them on the MPAI resources, you have some key images. So what are our next stop? Our next stop will be to develop a set of API to facilitate the use of MPAI and NW reference software. So the idea will be to be able to automate through API the sequence of action Carl just show you lively. This will be the first perspective. The second one will be related to the usage. We show you this possibility for a specific use case, question answering, and for a specific particular watermarking procedure. So just to show you the compatibility and the proof of concept. So what we like it will be to elaborate more on that and to provide for some main MPAI use case the effective usage with a selection of neural network watermarking method available as open source. And as I already announced, as I, let's say, spoil, this is today not only an MPAI standard, but it passed successfully the process of IEEE standardization. So it can be defined as IEEE 3304 standard. So you have information about MPAI on how to join. It's on the community website, and sure, join MPAI to share the fun and to build the future. I'm thankful for your listening, and let's go to the discussions.